All right, so in this video, I'd like to just go over just the basic rules of how we're going to plot data and reach conclusions here in the physics lab. So this week, one of the experiments that we looked at was the pendulum lab to deduce the acceleration due to gravity. And you can see that sort of skeleton procedure, a very sort of basic procedure was to just plot the time squared against the length. And then we're going to set the slope of our best fit line equal to the term 4 pi squared over g, because the theory suggests that the time period of oscillation is equal to 2 times pi times the square root of the length of the pendulum string over g. So we saw a little bit of sort of manipulation with that, and you can kind of see here that if we think about the equation of a line y equals mx, and we're mindful to plot t squared, that quantity on the y-axis, against the length on the x-axis, then this term right here, 4 pi squared over g, would be equal to the slope. So we can plot all the data, determine the slope, and then use that to solve for g. Let me go over some of those rules here. So here we see a piece of graph paper. We're going to construct some axes, label them accordingly. So the length L in meters m, the time squared in seconds squared. Scale the axes reasonably. Use most of the page. You should spread the data out over more than half of the page. Once you do that, then you can plot your data. So I think we got 1, 2, 3, 4, 5, 6. There's our 7th data point right there. Draw a best fit line that represents the trend in the data. And then find points like these, which intersect the gridding of your graph paper. So there's a good point right there that intersects the gridding of the graph. There's another good point down there that intersects the gridding of the graph. So I can read off their coordinates, x1, y1, x2, y2, just in terms of the general x and y, or L1 times squared 1, L2 times squared 2, right? What the data points actually represent. And then the slope is just the rise over the run, the difference in the y's over the difference in the x's. And then you would set your slope, once you have the numerical value, to 4 pi squared over g. It looks like this part of it here, something got erased, but it's correct down here. All right, and so that's how you're going to go about plotting data and reaching a conclusion where you're going to have to set the slope equal to some term that's based sort of on the theory there.